It's time to export the knowledge. In this video, we'll be doing some linear review. I advise that if you don't understand something in this video, you should do more review before watching other methods videos. This doesn't appear in the area of studies. However, it does appear in outcome 1 for unit 1 multiple times. So this is basically assumed knowledge. So let's start with a review of linear equations. It's a type of polynomial equation with only one unknown variable, which is to the first power. That's a lot of jargon, so let's break it down. One variable to the first power are things like 2x plus 1 equals 3, or 2x equals x plus 1, and x plus 1 over 2 minus x plus 1 over 3 equals 10. These are all linear equations because you can see that we only have the one variable x. So our variable x is only to the first power, meaning that we can't have things like x squared. No. That's not linear. One of the most important skills that you have to have down pat is solving for the unknown variable. So let's look at some example questions. We'll do some basic ones and then we'll work our way up. So let's do this one here. 2x plus 1 equals 3. Alright, so we can subtract 1 on both sides, get 2x equals 2, and then we can divide by 2 on both sides to get x equals 1. And you could have done that by inspection, but you need to show the mathematical work out. So what we just did is called solving for x. So we basically said, what is x? And we found out x is 1. This is also called making x the subject. So what I'm saying by that is x is this. We also have variables on both sides of the equation. So let's do 2x equals x plus 1. So this is another type of equation that you can see. So we can just subtract x on both sides and we'll get x equals 1 and we're done. We also have things like brackets. For example, 2 lots of x plus 1 equals 6. Alright, so there's two ways that we can do this. We can expand here or we can just divide. So I'm going to do both. So let's expand first. So this will become 2x plus 2 equals 6. Subtract 2 on both sides. 2x equals 4. Divide by 2x equals 2. Do it on the other side and just divide first. Get x plus 1 equals 3. Subtract 1. X equals 2. So both ways we can see that we got the same answer. Our linear equations can also look something like this. So we have x plus 1 over 2 minus x plus 1 over 3 equals 10. So how can we solve this? So the key thing here is that to realize, hold on, we have two different fractions here. So we're going to have to find the lowest common multiple. In this case, it's 6. So we can times by 6 on both sides of the equation to get rid of the fraction. So keep in mind of that. If you don't like timesing by 6, which is what we're doing anyway, you can just times by 3 and then times by 2. They're exactly the same thing. I'm just doing it in one step. So if we do that, we'll have 3 lots of x plus 1 from here, and then I'll have minus 2 lots of x plus 1, and that'll equal 60. Notice how this is a minus 2. Lucky for us, these fractions contain the same thing, so we can actually collect like terms. So we can go 3 minus 2, which is 1. So we now have one lot. One lot of x plus 1 equals 60. Subtract 1, x equals 59. Now we can also have x in the denominator. Here we have x in the denominator, and that's not good. So we need to get that out of the denominator. That's fairly easy. We can just times both sides by x plus 1. And this isn't a quadratic, so this is just an denominator, remember. So you will cancel out the fraction here, so we'll get 4. And then subtract 2 lots of x plus 1. And then on the other side, we'll have negative that, so we'll have minus x, and I'm going to expand in, so we have x minus 1. We can expand this if we want. We can bring this over here and bring it over there. So I'm going to expand 4 minus 2x minus 2 equal minus x minus 1. I'm going to bring the x over here and add 1. So 3 equal x, and we don't want x on the right hand side, even though it's fine. X equals 3. Solved. Alright, so another thing that we have to keep in mind are things called literal equations. These are equations where all of the coefficients and constants are pronumerate. Things like ax plus b equals c, or something like that. The process of solving for these equations are the same. We just do what we normally would, but we have letters in the mix instead of numbers. So if we were to solve for this equation, subtract b both sides, have a x equal to c minus b, divide by a, we get x equal to c minus b over a. Before I move on, I want to explain how to solve these types of questions on the CAS calculator. So I'm using the Texas Instruments TI Inspire CAS. Once I show you the method for solving, you need to understand that you can't just use the CAS for every question. It'll be faster if you do it by hand, and it will get you more marks if you do it by hand. With that in mind, let me show you. So you have to make sure that you open a calculator document, which is this little calculator symbol here on the home screen. Alternatively, you can go to a new document, and then you can hit add calculator. It's the first option. And now that we're in the calculator document, we can type solve, and then open some brackets, and then we'll put in the equation that we want, equals, let's say 3. And then we'll put in the variable that we're solving for. In this case, we want x. And then we just hit enter, and it gives us the answer on the right hand side here. So x equals 1. Very, very simple, very easy. Alternatively, you can hit menu, and then go to algebra, and then solve. So rather than typing it with the ABC keypad down here, you can just go that. And then you can type in whatever you want, equals 3 and x, and bang, solved. You can also remember the keybind, menu 3, 1, so menu 31. Alright, next thing that we need to talk about is how to get equations from worded questions. So often in tests or exams, they have worded problems and try and see if you can apply what you've learnt to some real world application. This is part of your assessment and part of outcome 2 of the unit. So let's look at the worded question. An investor invested $2,000 into a bank. The simple interest owed is $10 per annum. What is the rate per annum? Alright, very simple. You just need to know what simple interest is and how to relate it. So, key info here. The amount, what we're solving for, we want the rate. And simple interest is also key here. So, if you know what simple interest formula, interest equals principal times rate times time, but since we know the interest per annum is $10 and we want the rate per annum, we don't need to worry about time at all. So now we can just sub in the values. So we have 10 equals 2,000, and then we have the rate that we're solving for. So now we just need to divide. So rate equals 1 over 200. Now, in worded questions like this, they expect a worded response. So you're missing an easy mark if you forget to write a worded response. So write therefore with the three dots. So this three dot thing here, that just says therefore. That's the mathematical symbol for it. Therefore, the rate per annum is, and then you can give this as a percentage or as a decimal or as the fraction here, whatever. But if the question specifies to put it in whatever units it wants. So I'm just going to say 1 over 200. In worded questions, it's easy to get lost in the language. Just need to get the important information out so you see how I highlighted exactly what I was going to use. I knew it was simple interest, so that's how I would relate the values. I knew that I was solving for rate. Alright, moving on to the next segment. Simultaneous equations. Something to note is that we can't simultaneously solve linear equations. So things like x plus 1 equals 3. No, we can't simultaneously solve those. We can simultaneously solve linear relations. So y equals x. The word relation implies that there's a relationship between two variables. In this case, it's y and x, or x and y, whatever you want to call it. And x and y doesn't have a single solution, since x and y have unique solutions for each pair of x and y, you can say that they have a linear relationship. So graphically, if we wanted to solve a two linear relations, it'll be the intersection point here. Now, it's also important to know that sometimes you won't get a single solution like this. So sometimes you'll have, here's your xy plane and your lines never meet, they're parallel, so therefore there's no solutions. There's also the chance that it might be on top of each other. So what looks like one line is actually two. So I've have two equations on top of each other and they're equal to each other at every point. Okay, so there are two methods to solving these simultaneous equations. There's substitution and elimination. So both methods are required to be known. First, let's go over substitution. If we had x plus 3y equals 12, and that'll be our first equation. And our second equation is y equals 2x minus 3, and that's our second equation. All we can do is, since we know what y is in terms of x, we can substitute that in. So we'll say sub equation 2 into equation 1. So have x plus 3 lots of 2x minus 3, and that equals 12. And then we can just solve from there. So quickly expanding, we'll have x plus 6x minus 9 equals 12. 7x equals 21, so x equals 3. So now we can substitute x equals 3 into one of these equations and then solve for y. Now in this case, it's very easy to just substitute into equation 2, since y is already the subject of the equation. So let's do that real quick. Y equals 2 lots of 3 minus 3. Y has to equal 6 minus 3, which equals 3. And then our solution will be 3 comma 3, and we're done. So that's the substitution method. Now we need to look at the elimination method. We have 2x plus 3y equals 12, and 3x plus 2y equals 8. And we wanted to solve these. Need to make sure that the coefficients of the pronumerals have to match. So in this case, they don't match. So here I have 3 and 2, they're not equal to each other. Here I have 2 and 3, they don't match. So I'm going to have to do something to these equations here. Here's my two equations. I'm going to have to times them by some amount so I can perform some cancelling. So I'll times top equation by 2, equation 1 times 2. And what is that? That is 4x plus 6y equals 24. And I will call that 1 dash, but you can also call that equation 3, whatever you call it. Second equation, I'll times by 3, so I get 9x plus 6y equals 24. Now by inspection, you can see that x should equal 0, but when you subtract these, you get 0, the y's will cancel, and then you'll have 4 minus 9, lots of x, or you can have 9 minus 4. Either way, you're going to get x equals 0. And then you can sub that back in and solve for y like we have been. So might as well sub it into here. Let's just do it in our heads. 3 times nothing is nothing, so 2y equals 8. So y has to equal 4, so our solution is 0, 4. So just like before, we can solve these relations on the CAS. So there are two methods on solving for the CAS through the calculator document or the graphs application. So this is the calculator here. Just selected. That's the calculator. That's the graphs. So we can solve these both ways. So let's do the calculator first. Go to menu, algebra, solve systems of equations. And there's two options here. There's solve system of linear equations or solve system of equations. Both ways work in this case. This bottom one here is designed for only linear equations, but you can just use the first one. Now, here you'll see the pop-up that will appear on your CAS. So we'll have the number of equations, which in this case is 2, but you can bring them up or down or whatever you need, and then you have to specify the variables that you're going to use and what order. So x before y, and that'll be the two variables that we're solving for. So you hit OK, and then you'll see something like this. So now we need to just put the equations in. Might as well put in the example that we had before, 2x plus 3y equals 12, and in the second one we had 3x plus 2y equals 8, and then we just hit enter, and you can see x equals 0 and y equals 4. Now, you can also make a new document and add a graph. So here we have to go to menu and then graph entries / edit equation line, and then put in line standard. So now we've got the linear equations in, so we can just fill in boxes, and that equals 12. Enter, there it is. And we want another one, so let's put in another one, menu, graph entry / edit, equation, line standard. Here's our second equation, 3x, 2y, and equals 8. And you can see that there's an intersection there. Right, and then to find the intersection points, you go menu, geometry, points and lines, and then there should be intersection points. Hit enter, and then you just need to select the two graphs, and you can see that it popped up here 0, 4, and that's the intersection point. Okay, next bit, worded problems that need to be solved by simultaneous equations. To do this, you need to ensure that you understand what your variables are and how to relate them to each other. So it's something that will come with practice, but it's easy once you know the equations to solve for. So let's do an example. Bob the baker sells 2 items in his bakery. He sells cookies and donuts. Cookies cost $1.50, while donuts cost $2. He made $300 in the first week of January. He decided to change the price of cookies to $2 for the second week. He made $350 that week. If he sold the same amount of cookies and donuts each week, how many cookies and donuts did he sell in 1 week? give this a try. But as you do, I'm going to try and break this question down. So often, worded equations will do simultaneously solving, and worded questions, something like this. They try and overload you with words and sometimes irrelevant information. So the fact that it was January isn't really important to the problem. Sometimes they put extra names, so maybe Bob and Amy have a bakery. They try and overload you with and give you too much information, so you have to try and figure out, okay, what information am I actually after? Like, first week and second week aren't necessarily important. They're just things that to help you distinguish, oh, this is the first equation, this is the second one. So we start a question like this by defining our variables. So let's define them. Let x equal the number of cookies sold in 1 week. Alright, and let y equal number of donuts sold in 1 week. If we left out the in 1 week part, we would, if we left out the in 1 week part, we would saying number of cookies and donuts sold in total, which is not what we're solving for. We didn't specify the number of cookies instead of cookies sold. That could mean something else as well. The number of is basically telling us that we're expecting a whole answer, because we can't sell half a cookie. Question didn't say anything about half a cookie, half a donut, or something like that. So we're expecting whole answers here. Alright, so let's, looking back at the question, the first week, Bob made $300. So that's key. 300 has to equal some amount of X plus some amount of Y. So how much did it cost in the first week? Well, it cost $1.50 and $2 respectively. And this will have to add up to 300 somehow. We don't know what the X and Y are, but we know that they should add up to this. The second week, Bob made $350. He changed the price of cookies and he left donuts the same. And he made $50 profit, and we know that X and Y in this case are the same. So there's our two equations. Now that we have them, we know what we should be doing. It's pretty obvious looking at what this sort of question is. We're going to be simultaneously solving. Now that we have our equations, we can start solving. Conveniently, we can just subtract these since the coefficient of y are the same in both equations. So we can just subtract. Let's subtract equation 2 minus equation 1. Have 2 minus 1.5 x. That'll be just half of x, and this will become 350 minus 300, and that's just 50. So 50 equals x over 2 times by 2, 100 equals x. So Bob sold 100 cookies in 1 week. So we can sub that back into if one of our equations. Let's do it for equation 2. 350 equals 200 plus 2y. Subtract 200, we have 150 equals 2y. Divide by 2y equals 75. So Bob sold 75 donuts. Whole numbers, nice answers. Now again, worded problem, worded answer. We can't just stop here and say, oh, the solution was 100, 75. That means nothing. Write the therefore part. Therefore, number of cookies sold in 1 week was 100, while donuts, running out of space here, donuts were 75. Easy mark. Relate the result back to the question. Alright, next bit, linear inequalities. So they're exactly the same as linear equations. Instead of an equal signs, we have an inequality. So inequality signs, if you don't remember, are things like greater than or equal to, and less than or equal to. It's these things. So x is greater than or equal to, or x is greater than or something. Right? Those are inequalities. So a linear inequality will look something like x plus 1 is greater than 2. It behaves exactly the same. We can still subtract 1 on both sides. So x has to be greater than 1 to solve it. So if you pick anything that's greater than 1, it will satisfy this statement. So what we're doing when we're solving this is we're working out what value of x do I want to make the original statement true. Sometimes you'll be asked to construct this on a number line. Here's our number line here. There's 0. We said x has to be greater than 1. So there's 1, and here's -1, and we don't really care about the junk on the other sides. Now, pay attention to the inequality here. It is greater than, but not equal to. So x is not 1. So what we do here is we put a circle at 1, and then we draw an arrow out to represent all the numbers after that. So stop here, but don't actually include 1. So this is a sort of visual representation of the inequality. So if this was equal to, so x is greater than or equal to 1, instead of an open circle here, we would have a closed circle. So we just shade it in. Key difference. Okay, so we can also have, now there's one thing that doesn't behave quite as nicely. So when we had a negative an equal sign, we can just divide and nothing really matters, right? Done. However, if we have something like this, greater than or equal to 2, we can subtract 1, that's fine. When we divide by a negative or we times by a negative, the inequality will flip. X smaller than or equal to -1. See how it flipped? If we also had something like 1 is greater than or equal to x, and we wanted to make x the subject, we could flip it, x, but now we have to flip the inequality as well. Some things to keep in mind here. You need to know when and when not to flip. So let's do another example. So 2 minus x is smaller than or equal to x minus 4. You can add x on both sides. 2 is smaller than or equal to 2x minus 4. Add 4 onto the other side, so we have 6 is less than or equal to 2x. Divide by 2, 3 is smaller than or equal to x. If we want to flip it, x is now greater than or equal to 3. We can also solve inequalities on the CAS the same way we would with a regular expression. So when you would go to put in solve, instead of writing an equal sign, you just replace it with the inequality sign. You can find the inequality signs below the control button, and to access them, you need to hit control and then the equal sign. And then a little dialog will pop up, and then you just use your arrow keys to switch to the one that you want. Alright, last bit. Final stretch. We're nearly done. Last thing we need to talk about is what a formula is and how to use it. You already know formulae. Not formulas, formulae, that's the multiple. You just don't know the jargon for formulae. An equation with 2 or more variables that states some relationship is a formula. So an example is an area of a rectangle which has the formula area equals length times width. Nothing new, nothing special. We just now know this is a formula. Right, done. We also know a little bit more complicated ones like the volume of a sphere, 4 over 3 pi r cubed. If we didn't know the radius of a sphere but we knew its volume, we could find the radius by transposing the formula to make r the subject. So let's do that now. So we'll take the reciprocal, volume, 3 times volume over 4, and we'll take pi there as well. That's equal to r cubed. Then we just have the cube root. So radius equals the cube root of 3 times volume over 4 pi. So now I've transposed the formula to make r the subject of the equation, and now we can just sub in our volume and we can work out what the radius is. Some questions ask for you to transpose and then solve for something. So they'll give you this equation and then they'll say the volume is this, what is R? And then they'll often say transpose it first and then solve, but you can just put in your volume in and then solve as you go in one step. Alright, so that's it for this video. If you have any questions, feel free to leave a comment or contact me on social media, and I will see you in the next video.